You're going to have to draw those, guys. I'm not doing it. It takes too much time right now, but it is on the test. Find the surface area of a pentagonal pyramid if the base edges are 10 and the height that's inside the shape is 7. So the height would form a right triangle. So we have a right triangle inside the shape with the height, the apothem, and the slant height. I need the apothem. Well, I have to work on the pyramid anyways. So let's look at how does the apothem work? The apothem would be like this red triangle on the base. That is a different triangle. We're going to work on this triangle that has the apothem, half of a base edge, and the radius. That's the one we always work on for regular polygons. So let's get it going. 360, there would be 10 of those, so 36 degrees each. This would be 5. I'm going to call the apothem A. So this would be a tangent of 36 equals opposite over adjacent. So the apothem equals 5 over the tangent of 36. So find the surface area. So we want the entire surface area. So that would be 1/2 times the apothem times the perimeter. 10 times 5 is 50. So that would be 25 times 5. That would be 125 over the tangent of 36. So that's the area of the base. Well, we need to get, if we're doing the surface area of a pyramid, that is 1/2 PL plus B. We have P, we have B, right? We know the perimeter is 10 times 5 is 50. I just wrote the B. We need that L. I'm going to take the apothem and I'm going to plug it in to this other right triangle. Yes. So this is 5 over tan 36. So Pythagorean theorem over here, the slant height is going to equal the square root of 7 squared plus parentheses 5 over tan 36 squared. Now I have my slant height. I'm just going to leave it like that. So I don't have a ton of room. I'm going to work above. The surface area is going to be 1/2 times the perimeter, which is 50, times the slant height, which is the square root of 7 squared plus 5 over tan 36 squared. So that's 1/2 pi RL. Sorry, 1/2 PL plus B plus 125 over tan 36. Type that in, 0.5 times 50 times the square root of 7 squared plus parentheses 5 over tan 36 parentheses squared. All of that plus 125 over the tangent of 36. And I get 417.456. 1/2 PL. I think that's right. Okay. Find the area of the region bounded by those graphs. -3/2 x plus 10. Plus 10 down 1, 2, 3 over 1, 2. 1, 2, 3, 1, 2. Thank you, Notability. Finish the job. X equals 0. Well, x equals 0 is just the y-axis. Y equals 1. And y equals 7. So we have another trapezoid. We have a base of 2. We have a base of 6. And we have a height of 6. So the bases, the average of the bases times the height would be 6 divided by 2, that's 3. That's 8 times 3 is 24. A circle is inscribed in an octagon. So if the circle is inside the octagon, that means that the circle, my picture is not great, but the bottom line is you need to realize that the apothem is the radius of the circle if the circle is inside the octagon. So if the radius of the circle is 5, then the apothem is 5. So I'm going to work on the octagon, right triangle. Right, we're doing this right triangle here. 360 divided by 16 is 22.5. The radius of the circle is 5. So the apothem of the octagon is 5. That's because the circle is on the inside. On the last review, the circle was on the outside, and it was a different situation. Pay attention to the differences. If you don't understand my drawing, Google circle inscribed in octagon and look at it. Find a circle inside of an octagon. You'll understand a little bit better. What is the percentage of the octagon that the circle takes up? Well, let's find the area of both. So I need to find this side. So the tangent of 22.5 equals opposite over adjacent. So that is 5 times the tangent of 22.5. There would be 16 of those. So that would be 80 tangent of 22.5 would be my perimeter. So the area of the circle, not the circle, the octagon would be 1/2 times the apothem times the perimeter, 80 tangent 22.5. So that would be half of 80, 40. 40 times 5, that would be 200 tan 22.5. So the circle, area of a circle is just pi r squared, so the circle would be 25 pi. So what percentage of the octagon does the circle take up? So it's the part we care about, the circle, divided by the octagon, which is 200 tan 22.5 times 100. So that would be 25 pi over, those would cancel out, that would be 2 tan 22.5. That's the exact answer. If we type that in, let's see here. And, oh, sorry, we typed the wrong thing. Sorry, guys. 2 tan 22.5. All right. And that is 94.806. And that's the percent. The area of a rectangle is cut in half. How could this done by only changing the length? Well, just cut the length in half. That would cut the area in half. What would happen to the area of a kite if you doubled one diagonal and divided the other diagonal by 2? So the area of a kite is 1/2 d1 d2. So if we changed it to be 1/2 double the first one and multiply the second one by 5, divided by 5, sorry. Double the first one and 1/5 the second one. What's the overall effect? Well, 2 times 1/5, that's 2/5 times 1/2 d1 d2. Well, that's just the original area, so it'd be times 2/5. Find the area of the solid. All right, we need every surface accounted for. There's lots of ways to think about this, but the easiest way for most people, total of the big box minus this rectangle, that is a covered up rectangle, minus one rectangle, plus the total of the small box. Again, when you do the total of the small box, you have to minus that one rectangle. If you know a better way to do it, do it. I know lots of better ways. If you get the same answer as I do, you're okay. This is the way that's the easiest to understand for the majority of people. So I need to work on both boxes. I'm going to work on the big box first. I'm going to draw its base. Its base is 35 by 20. And I need P, I need B, and I need H to get the total of the big box. P would be 55 times 2. B would be 700. And H would be this distance, 15. So PH plus 2B, 110 times 15 plus 2 times 700, that's 3,050. That's the big box. Okay, I'm working on the small box now. Small box, the base on the small box is, what is it? It is 18 by 21. So I need P, I need B, I need H. 2039 times 2 be 78. Okay, I just want to make sure I got that right. So the perimeter is 78. 18 times 21. The area is 378. And the height on that situation would be 9. So pH 78 times 9 plus 2b, 2 times 378. So 78 times 9 plus 2 times 378 would be 1458. And then the two rectangles, the rectangles are these 21 by 18 rectangles. 2 times 21 times 18, right? There's two of them. 2 times 21 times 18 is 756, right? We're subtracting it twice. We're subtracting it once on the big shape when we did the big shape. We're subtracting it once on the small shape. So this plus this minus that, 3050 plus 1458 minus 756, and I get 3752. Hopefully these are correct. I will check my answers again later. Find the lateral surface area of the solid. 60 degrees is gone. So how much of the original cylinder can we still see? We can still see 300 out of 360, which reduces to 5/6. We're only doing lateral. So the lateral of a cylinder is 2 pi RH, but we don't have the entire cylinder. We have 5/6 of it. So we're going to do 5/6 times 2 pi times R times H. Now that does not include the two new rectangles. I'm going to add 2 times 6 times 12, right? Those rectangles are 6 by 12. So this is the situation. So let's see here, 2 times 6 times 12. So this is 144. And then these are the same numbers just with pi. So that's 144 pi times 5/6. So that's 120 pi plus 144. That's the exact answer. That's the lateral. No bases. No 2 pi r squared. No bases. Just lateral. Find the surface area of the resulting solid when the rectangle that is 3 units away is rotated about the axis. So I would draw the rectangle across the axis and draw circles to connect vertices. And we had this picture on the last assignment. It's a cylinder with a cylinder cut out. I'm not going to go over every little detail. Look at the last video and how I did that one if you need to. But the basic premise is we're going to do the total of the big minus the two small circles that are gone plus the lateral of the small. That's the plan. Big R would be 3 plus 11 is 14. Little r would just be 3. And the height of both is 8. So here we go. The total of the big would be 2 pi times big R times 8 plus 2 pi times big R squared. Minus the two small circles, 2 pi times little r squared plus 2 pi times little r times h plus the lateral of the small. So 2 times 14 times 8 plus, I don't type the pi's in my calculator, guys, because they all have pi in it. Plus, so 2 times 14 times 8 plus 2 times 14 squared minus 2 times 3 squared plus 2 times 3 times 8. And I get 646 pi. That's the exact answer. If they said rounded, I would type it in. The surface area of a typical micro machine is that 87:1. So if it's 87:1, I got to square that. And that's going to be 7569:1, right? 1 squared is just 1. And that equals, let's see here, that equals 8640 over something. So 8640 times 1 divided by 7569. And so what is the surface area of a micro machine? It'd be 1.141 inches squared. Got it.